Water is moving, fast, in the middle of nowhere. No hills around it, no rain above it, just sand stretching in every direction. This location has no name on old maps. No river ever ran here, until now. Excavators tear into rock 200 kilometers from the nearest city. They are not laying a pipeline. They are not burying a cable. They are building a river, by hand, through ground that hits 55 degrees by 9 in the morning. 310 kilometers of it, cut straight through the harshest desert on Earth. On paper, hydrologists said this couldn't work. The land tilts the wrong way. Gravity should stop this water in its tracks. It didn't.
It's an impossible sight, this rushing blue water amidst the endless dunes. A testament to human ingenuity, perhaps, or something far more mysterious.
95% of Egypt's population survives on 4% of its land. Cities are choking. Farmland is disappearing under concrete, and the Nile River is stretched to its absolute physical limits. To understand this colossal gamble, look at a satellite map of Egypt taken at night. It is like squeezing the entire population of the United Kingdom into a space smaller than Switzerland. Beyond that thin green line of the Nile lies 95% empty, punishing desert. If engineers could transform just a fraction of that wasteland into green fields, nationwide disaster could be avoided. Early proposals suggested digging conventional irrigation canals directly off the main river. But conventional canal designs failed instantly when tested in desert computer models. The scorching ground absorbed liquid like a dry sponge, while blistering heat evaporated millions of liters daily into thin air. Digging a simple ditch in sand meant every drop of precious river water would disappear within 5 kilometers. Even worse, desert soil contains hidden salt crusts buried beneath centuries of undisturbed dust. When unlined water touches these salts, it creates a toxic, saline mud that destroys crops instantly. Engineers faced a double disaster, losing their water to evaporation while simultaneously poisoning the surrounding soil. To make matters harder, the elevation of the Western Desert rises significantly higher than Lake Nasser behind the Aswan Dam. Water does not flow uphill without external force, meaning simple gravity could never pull the canal forward naturally. You are trying to make a river run backward across a furnace. International consultants warned during early planning phases. Initial cost estimates reached astronomical levels. Enough money to build 10 major international airports simultaneously.
Critics labeled the dream a political fantasy, predicting machinery would rust long before water ever reached the distant oases. Yet doing nothing meant watching cities collapse under demographic pressure within decades. Surveying crews ventured deep into isolated terrain where temperatures topped 55 degrees Celsius in the shade. Tires melted off vehicles, and precision optical equipment malfunctioned in the shimmering heat waves. They needed a completely new way to move massive volumes of liquid across elevation barriers without losing a drop. The entire existence of future generations hung on solving a seemingly impossible fluid dynamics puzzle. The turning point arrived with a radically ambitious multi-stage engineering master plan known officially as the Toshka project. Instead of relying on simple flow, engineers designed the world's largest stationary water pumping station at Lake Nasser's edge. This massive structure, the Mubarak Pumping Station, acts like a human heart, forcefully lifting river water 50 meters skyward. That vertical lift is equal to pushing a river to the top of a 15-story building every single second. Once elevated, the water dumps into a giant concrete-lined channel called the Sheikh Zayed Canal. To stop water from sinking into the earth, engineers specified a multi-layered waterproof barrier beneath heavy concrete slabs. We are effectively building a giant plastic and concrete slide across the desert, lead designers explained. Special geometry was calculated to keep water moving at precise speeds, fast enough to prevent silt settling, slow enough to curb evaporation. It was a masterclass in hydraulic balancing, designed to turn a harsh wilderness into 500,000 acres of farmland.
Standing here at the edge of Lake Nasser, you can truly appreciate the scale of the Mubarak Pumping Station. It is the heart of the Toshka project. And
with the blueprinted design validated by international experts, heavy equipment moved into position along the desolate route. The real war was about to begin, not on paper, but against millions of tons of stubborn desert rock. Right now, hundreds of massive excavators bite into hard granite, throwing blinding dust into the scorching desert air. Operators work around the clock in air-conditioned cabs, their instruments tracking GPS coordinates down to the millimeter. To build the primary channel, workers must remove over 200 million cubic meters of sand and solid stone. That volume of excavated rock is enough to reconstruct the Great Pyramid of Giza 80 times over. Specialized trench lining machines straddle the wide excavation, crawling forward at a deliberate, steady pace. A continuous stream of specialized concrete flows into place, forming smooth walls and floor panels in one seamless operation.
Keep it coming.
Beneath the concrete, crews lay heavy synthetic waterproof membranes to seal every microscopic crack against water loss. Right now, a welder inspects a seam, his mask reflecting bright sparks against the vast open expanse. One tiny tear in the plastic liner could allow millions of liters to leak out, undermining the foundation underneath. Temperatures inside the canal bed regularly exceed 50 degrees, threatening to dry the concrete before it cures properly. Engineers mix ice directly into the concrete batching plants to lower temperatures and prevent structural cracking. It is an incredible race against environmental physics, operating in conditions that break standard construction equipment. Rubber hoses snap, hydraulic fluid overheats, and fine sand destroys engine filters in a matter of days. Yet the channel advances several hundred meters every single day, stretching farther into the silent wasteland.
Massive bridges are constructed over empty sand to allow future desert highways and local traffic to cross safely. An engineer verifies structural alignment using laser levels, satisfied as the readings match theoretical targets precisely. The raw trench is complete, but the heart of the entire project still needs to be brought online. At the head of the canal sits the Mubarak Pumping Station, anchored deep into the rock floor of Lake Nasser. The station is built inside a massive island structure surrounded entirely by deep reservoir water. Inside its concrete belly lie 24 massive electric pumps, each standing as tall as a 3-story house. When fully active, these pumps consume enough electrical energy to power a city of 2 million inhabitants. They pull raw water directly from the lake through heavy intake grates designed to block debris and fish. The liquid shoots upward through heavy steel pipes, discharging into the elevated main canal headworks with incredible force. From there, gravity takes over as the water slides down a continuous, imperceptible slope along the primary channel. The slope drops just a few centimeters per kilometer, a slope so shallow it looks completely flat to the human eye. This subtle angle maintains steady water velocity, minimizing friction against concrete walls while preventing stagnation. Along the 310-kilometer path, smart control gates automatically regulate water depth and flow rates. Sensors transmit real-time data to a central control room, monitoring temperature, flow speed, and water loss instantly. Secondary branches split off from the main channel, channeling water directly toward thousands of agricultural pivot fields.
Giant overhead sprinklers spin continuously, spraying fine mists over vast circular fields of wheat and palm trees. What was once barren yellow dust is rapidly turning into geometric patterns of rich, vibrant green. Right now, operators push control levers forward as the main station prepares for a full-scale operational trial. The giant pump turbines hum to life, sending low vibrations through thousands of tons of reinforced concrete foundations. Millions of liters of fresh water surge through the intake pipes, cascading into the dry concrete channel head for the first time. Engineers watch anxiously from high-access catwalks as a wall of blue water rushes down the pristine white trench.
Exactly what we projected.
Check the side seams, a technician radios down, watching for any sign of structural leakage or foundation
This
settling.
incredible canal is transforming the landscape. It brings life to one of the driest places on Earth. This is the future of desert reclamation.
The waterfront advances steadily, filling side branches and surging deep into territory that hasn't seen moisture for millennia. Sensors confirm zero significant leakage along the concrete floor. The multi-layered waterproof barrier has held perfectly. Massive central pivot sprinklers spring to life, spraying cool water over acres of newly planted, wheat-seeded ground. In the heart of the western desert, farm workers watch in awe as fresh green shoots burst through the soil. Today, the Sheikh Zayed Canal stretches 310 kilometers into regions once considered completely uninhabitable. Hundreds of thousands of acres of new farmland produce wheat, fruits, and vegetables, feeding millions of Egyptian families. New towns, research centers, and processing plants are springing up along the water route, relieving strain on overcrowded urban hubs. The project proves that human engineering can adapt severe landscapes, securing critical food resources in an uncertain world. Where ancient sands once swept over empty dunes, satellite images now show striking green circles spreading across the map. Egypt did not just build a water canal. It altered its own geographical destiny through sheer engineering determination. And far out in the quiet desert, a man-made river continues to flow, proof that even the harshest wilderness can be tamed.